The core must be compact and surrounded by an effective neutron reflector, for example, beryllium. The direction of movement of the coolant in the fuel assembly should be from bottom to top using a chimney with a side outlet to remove the heated coolant from the pool. The upper location of the working elements of the control and protection system provides optimal cooling conditions for the core, taking into account the shift of the neutron flux to the lower part. The maximum neutron flux in the moderating cavity of the central channel is achieved at the level of 10 to the 15th power neutron per square centimeter per second. The central channel body serves as a linear guide for moving the fuel assembly fixing device and the chimney cover. The fuel assembly fixing device is designed to prevent them from floating under the influence of the ascending coolant flow. Another function of the fuel assembly fixing device is to ensure increased pressure in the core due to pressure losses occurring on the fixing elements. This scheme of coolant circulation through the core ensures maximum coolant velocity in the fuel assembly while effectively using the pressure characteristics of circulation pumps. The chimney cover with holes for the passage of the control rod guide pipes prevents bypass of the core when the reactor is operating at power. During periodic reloading of fuel assemblies, the fixing device and the cover rise upward, freeing up space for carrying out transport and technological operations. Cooling of the reflector blocks and vertical channels in the reflector is carried out by pool water with downward movement of the coolant. For this purpose, a suction chamber is located under the reflector, from which the heated coolant is directed to the oxygen activity suppressor of the reactor. The coolant enters the pool for subsequent cooling of the reflector through an opening in the pressure chamber located under the reactor core. When the pumps are completely stopped, the transition to natural circulation in the core is made automatically after the opening of passive valves that are triggered when the pressure in the chimney increases. After opening the intrabasin natural circulation circuit through the hole in the pressure chamber, the core, and passive valves, safe removal of residual heat in the core during cooldown of the reactor is ensured. More detailed information on the thermal parameters of core cooling can be found at the link below.